Now we will use linear models. And what that means is that when we have a linear equation or relationship, we can model real world situations. So we will connect the abstract world of x's and y's that relate to each other with a constant rate of change with actual real world situations, which you see will be applicable many times, though not all times. So, how do you know if a linear model is appropriate? Well, you will know a linear model is appropriate if the rate of change stays the same, or if rate of change is constant. If the rate of change is not constant, you do not have a uh, relationship which is appropriate or a relationship that is linear. So let's just quickly recap slope and intercept. And I'll do that verbally. So slope is the rate of change. So if an x value changes a given amount, a y will change a corresponding amount. That is our slope. So, and you've often seen it in these videos summed up as rise over run. Rise over run. So for every one, or for every one we increase on the y-axis, we increase a half on the run axis, or delta y over delta x. All of these are examples of one another. And our intercept is our starting point. That is where we begin, our y-intercept. That is when x equals 0. So let's get into an application. Okay? And we're going to apply what we've learned about uh, linear equations, slope-intercept form, stuff like this. So application, and the application is going to be cost with fixed rate. Fixed rate. Cost with fixed rate. And let's use this example. Let's say that a gym, and this is a real world example, a gym charges a $20 sign up fee and $10 monthly from that point on, and $10 monthly. So what you have here is an excellent candidate for a linear model. And think about that for a second. Why is this a linear model? What does each of these words represent? What is $20? What does that represent? What does $10 represent? So let's do it this way. Let's say y equals 10x plus let's see, let's switch colors real quick, plus 20. Okay, what do each of these represent? Well, let's think about this. Okay, $20 sign up. $20 sign up. This is our y-intercept. When we go to the gym, automatically we're going to spend $20, whether we sign up and stick with it for 6 months or 1 month. $20 is going to be spent. Then we're given our slope, $10 monthly. we're going to increase by $10 every month that we attend the gym. So you see that your sign-up fee represents your y-intercept, and your monthly charge represents your slope. Let's read meaning from an equation, but first I'm going to erase what's on the board. Here I've asked you to read the meaning of y equals 5x plus 15. So think about it for a moment, pause if necessary, but allow me to explain. So we're given y equals 5x plus 15. Here we have our slope, and our slope is our rate of change, and here we're given our y-intercept. Our y-intercept is our starting point. So when we see this, 5 represents the 5 is the rate of change. Rate of change, and 15 represents 15 is our starting point. And given these two values, we can create a table, an x and a y table. And on that table, we will start at x equals 0 and y equals 15. Now, when we increase y by 5, so we go to 20, what now does x become? Becomes 1, and so on, 2 and 25. So now we understand that we're given our slope, our intercept, we create a table, and we're given a constant rate of change. For every 1 we increase here, we increase 5 there. So let me create a table first, and then we will write the equation from the table. But first, let me erase. Here we're given a table, and I would like you to think about that table. If you can, write it down as an equation. Okay, so let's consider this. What's going on? On the x side, we're changing 1, and on the y side, we're changing 4 each time. That happens again and again. The pattern holds. +1, +1. The pattern is holding for us. So that means we have a linear model. All right, so we can write this as y equals 4, because we rise 4, x. And what is our x-intercept? Our y-intercept. Well, it's 12, because our y-intercept occurs when x equals 0, and when x equals 0, y equals 12. So here is our linear equation given this table. Tables often hide equations. We uncover them. Now, let's think about when a linear model will not work. Here we're given the table of x and y. When x equals 1, y equals 2. When x equals 2, y equals 4. So we see that on the x values, we're increasing 1 each time. But let's take a look at the y here. And this time we added 2. Then on the next jump, we added 5. But what it really looks like we're doing is multiplying by 2. Multiplying by 2 each time. This is not a linear model. This model is increasing, because if we went to 4, we then increase by 16, and so on, and that is a plus 6. We're increasing at a different rate each time. So this is not a linear model and will not work. You must ask yourself, is the change constant? If the answer is no, then you do not have a linear equation or model. Some of the common mistakes that people make when dealing with these types of problems is confusing what slope and intercept represent. So they may get confused about when we have the y-intercept, what does that mean? And what you need to know is that is where the that is where x equals 0. And another thing that students often mix up is assuming that all situations are linear and trying to force things to work that way. That's simply not the case, as you've seen here. So now let's do a set of practice problems. Here's problem number 1. We're told a parking garage charges $5 to enter and $3 per hour. And we'll assume for this equation that anything between 0 and 1 hour will be rounded up, and anything between 1 and 2 hours will be rounded up. So go ahead, pause the video, and create an equation that represents this, and you may need to create a table to understand how to write the equation. Okay, so I'm going to start by actually creating a table. That helps me understand what I need to do. And let's write it this way. Let's not mince words. We're not even going to use x and y. We're going to use hours and dollars. And let's start at 0 hours. Let's say you've entered the parking garage and you're at 0 hours. This would be your y-intercept. How many dollars will this cost you? It would be $5. You paid $5 to get in there. And let's say you're at 1 hour. You've been in the parking garage for 1 hour or 55 minutes. Or actually, let's rephrase that. I don't want to confuse you there. Let's say you've been you were charged an additional $3 for every hour on the hour. So let's say you've been in there for 1 hour. You will have been charged $3. You will now be at $8. And now after 2 hours, you will be charged an additional $3, which puts you at $11. So we found that we have a constant rate of change of plus 3. So we can write this as y equals a slope of 3x plus our intercept is 5, because at 0 hours we're charged $5. And this is our final answer. That's how we represent it with a linear equation. Let's move on to another question similar to this. So now we're given the word problem that a phone plan costs $40 per month plus $10 per gigabyte used. Well, I'm going to ask you to write an equation in slope-intercept form that represents this word problem. Okay, I'm going to start by, again, creating a table. This time we're going to make it a little more abstract. We're just going to say x and y. So when x equals 0, what will y equal? Well, you have to realize that a phone plan costs $40 per month. you're going to spend that regardless of how much data you use. So when x equals 0, y equals 4. And now for every gigabyte you use, you'll increase this by 1, and your total dollars spent will increase by 10. Now, with just these 2 points, we have enough to write our linear equation. And our linear equation would be represented as y equals 10x plus 40. And that is our final answer. Y equals 10x plus 40. And as you continued on, if let's say you took let's say you got out for summer break and you decided to watch Netflix all summer long, you would use a ton of gigabytes, and let's say you used 8 gigabytes. Well, we would find the total cost of that month by saying y equals 10 times 8 plus 40, and you would find that y equals 80 plus 40, which is 120. And you would spend $120 on that phone plan. And you would either be angry at yourself, or whoever pays your phone bill would be very angry at you. Let's move on to another problem where I'm going to give you a table and ask you if the situation is linear. So this is our table, and let's put our hours, and we're being asked, is this situation, as represented by a table, is it linear? Is it linear? If it's not, why is it not? If it is, it is. So let's take a look at this. So we have x is our independent variable, it's changing, and our dependent variable over here is plus 20 and then plus 25. Well, that's a red flag, because this rate of change is not constant. The rate of change is not constant. And that tells us that it's not constant, and that tells us that this is not a linear model. So no, it is not a linear model. Let's do one more problem. All right, for our fourth problem, we're given the question, a linear model has a slope of 4 and a y-intercept of -6. Write the equation and describe a situation it could represent. Okay, so go ahead and pause the video, go ahead and write the equation, which I'm sure will be easy for you, and also describe or think about a situation that could be represented by that model. And I have a situation that I'll show you. Okay, so just right off of the bat, we can say that y equals 4x plus, well, minus 6. And now, as for thinking about a situation that could represent, let's come down here, and here we have a situation. All right, we have an evil fisherman who is catching fish that are endangered and keeping them to eat them. And Mr. Crabman, the oceanic superhero he is, hears about this from his fish buddies. And he decides, I'm going to go up there, up this man-made slope, which has a perfect grade, that he's going to go up this slope and he's going to show evil fishermen a thing or two. So he starts here 6 meters below sea level, and after 1 second he travels 4 meters up. So he's traveling at 4 meters per second, a very superhero-ly speed. and he is going to go up there and teach him a thing or two. So that is a representation of that linear model. And he's going to travel at a constant speed because that's one of his superpowers. He always travels at a constant rate of speed, whatever that speed may be. Thank you for watching the video. If you got something useful, please like, subscribe, or leave a comment.